Hello everyone. Welcome back our Class BNC 31803 site investigation. Today we continue our class on Part 2 Chapter 4 Supported Excavation and Subsurface Works, Unsupported Excavations. Cut with free slopes in soft cohesive soils are limited to very shallow depths, maximum 3 meters. Require protection using different techniques such as 1. Slope protection against erosion using geotextile membrane. 2. Providing a filter layer made of gravel or single-grained concrete, whereby the filter stability requires additional attention. Geotextile filter mat may help to ensure the filter stability. 3. Stabilizing the slope by means of vacuum drainage. A. Without additional measure. B. Supported with timber piles and geotextile mat. Intermediate excavation stage. If berms and sloped excavations remain unprotected or unstabilized, delayed slides and mass flow can occur. The depth of excavation of unprotected excavation in soft soils should not exceed 3 meters. A slope up to 45:1:1 can be used for temporary slopes without a need further verification of its safety, provided that slope is located above groundwater. Excavation supports structures include all means and methods of preventing a collapse of the earth walls that surround an open excavation. Excavation support is generally required for excavations in excess of 6 feet, 1.8 meters, or excavation that are not sloped. Excavation support for deep excavations refers to the additional bracing that is required to stabilize a retaining wall such as a sheet pile when excavation gets typically deeper than 10 to 14 feet, 3 meters to 4.2 meters. Such excavation support systems comprise tiebacks, cross-lot steel struts, rakers, helical anchors, and top-down concrete slabs. OSHA has mandated that any excavation or trenching operation that goes 5 feet greater than or equal to below ground level must utilize an acceptable excavation support technique. Figure 13 shows the rock anchor excavation support system used in the World Trade Center in New York. Table 1 show the factors affecting the performance of supported excavations according to Mana 1978. We consider 3 types of parameter affecting the performance of supported excavations. 4 parameters under designer control are: 1. Type of support system. 2. Stiffness of support system. 3. Degree of wall embedment. 4. Degree of preloading. 4 parameters partially under design control are: 1. Method of support system construction. 2. Construction period. 3. Method of construction of structures within excavation. 4. Size of surcharge loads. 5. Weather. For fixed parameters not subject to design arc control are: 1. Subsoil conditions and properties. 2. Surrounding structures. 3. Excavation shape and depth, vertical and horizontal excavation. Vertical excavations are mainly for constructing shafts, basements, piles, piers, wall caissons and wells. Horizontal excavations are performed in the construction or installation of water supply and sewage pipelines, telecommunication and electrical cables, as well as roads and rail tunnels. Nonetheless, the methods of excavation and groundwater management used in both excavations are very similar. The primary differences between the vertical and horizontal excavations are given as follows. 1. Accessibility. As the working face of vertical excavation is horizontal, it is readily accessible, to be walked or driven on. For horizontal excavation, special platforms may be required to access the vertical working place. 2. Alignment. Alignment in a vertical excavation is assisted by gravity, that is using dead weights as loads and reactions in soil cutting system that hung by a cable. In horizontal excavations, reactions or anchorage are needed for pushing rigidly mounted drilling tools. 3. Removal of spoils, excavated soil cuttings or muck. For deep vertical excavations, hoist, lifts, and cranes are required to remove the spoils. Vertical excavations, which are shallow and wide, may only require inclined ramps for the spoils to be removed using dumpers and conveyor belts. Horizontal excavations present little problems in spoil removal due to accessibility by dumpers, drains or conveyor belts. 4. Side supports. As vertical excavations can be circular, square, rectangular or simply irregular shaped, there is variety of support systems to choose from. Horizontal excavations are usually circular or partly circular in shape, and are supported by providing circular elements of steel of concrete. Excavation methods and spoil removal. 1. Small-sized excavations. Manual methods with hand tools, hoes, shovels, pickaxes, etc. Pneumatic rotary drills or percussion tools, for example jackhammers, can be used in hard or stiff clays. 2. Vertical circular holes. Holes with diameter ranging from a few hundred millimeters to a few meters can be drilled using mechanized rotary augers, high-pressure water jets, percussion devices, for example balers and chisels, high-speed rotary drills. 3. Square or rectangular trenches of similar sizes. Excavated using clamshells, grabs, backhoes, special trenching tools or bucket wheel excavator. 4. Vertical excavation more than several meters wide. Within excavation area use shovels and backhoes. From ground surface use manual excavation or grabs. 5. Tunnels. For diameter 3 meters to 30 meters use manual, backhoe or full-face excavation with tunnel boring machines. Smaller tunnels use horizontal augers and micro-tunneling machines. 6. Excavation of river or seabeds. Executed from an anchored floating platform, for example dredgers, machines mounted on floating pontoons, barges and ships, which lower an excavating tool the bed to cut and remove the soil. Mechanical dredgers utilize grabs, backhoes and buckets for cutting and lifting the soil and use suction to lift the soil in the form of slurry through pipes lowered to the bed. Okay, that's all for today. We continue our class on the next section on excavation retaining systems in soft soils. Thank you for your attention. See you in the next class. Take care and bye.